along with that, which is the responding variable. So you're going to see all those words as answer choices: manipulated, responding, independent, dependent, control, and make sure you're focusing in on what the manipulated variable is. Alrighty, why are collaboration and communication important in science? Kind of happens with you guys doing homework. High school students doing homework. Why do you collaborate and communicate when you're working on homework assignments? Yeah, and what drives you to do that in the first place? And she can get it done, but you don't know the answer right away, right? If you look at a question, you don't know the answer right away, then you're going to try to find it somehow, and hopefully not just to get it done, but by actually working with somebody to help you understand it. So scientists want to collaborate and communicate so that they can expand on their experiments, so that they can get more information. Maybe a scientist in one country doesn't have access to some of the sophisticated equipment that a scientist in another country does, and the one with the better equipment can do an experiment and share information with the original scientist. Okay, they like to repeat their experiments, they like to verify the results, but it's kind of like having somebody else check your work. Or you write an essay for your English class and you have somebody proofread it and help you edit. Alrighty, the steps in problem solving. In either type of problem solving, what was the first step? Analyze. You got to look at that problem, figure out what information is given, what you know, and go from there. You'll see on these test hints that I think there's like 22 of them, but there's actually 25 questions on the test. So one test hint, like in theories, there's actually going to be 2 questions about that. But what we've covered will help you with both. Alrighty, explain the difference between conceptual problems and numeric problems. That should be pretty easy. The difference between a conceptual problem and a numeric problem, what does it sound like the difference is? One's with numbers and one isn't. Okay, so in a numeric problem, you're going to need to manipulate some data and do some calculations, and in a conceptual problem, it's a logic problem. You don't necessarily have to use math. On this particular question, I think it's another one where if you really take the time to read through all 4 answer choices, it'll be very easy. If you just read the answer choices quickly, it might sound like 2 or 3 of them could be right. So read those choices carefully. Now the next several questions are from that lab, the first big lab. So make sure you take that big packet home and look at that. We'll ask you questions about techniques, we'll ask you questions about safety. Fortunately, people did really well on the safety quiz, the lab technique and safety quiz. So, number 12 there, identify the safety equipment in our lab, and this will specifically ask about the fire safety equipment in this room. So what do we have for fire safety? We have fire blanket. What else?
Shower.
Is safety shower? That could be. I think there are some other things that would come first.
Extinguisher.
Fire extinguishers. What else? What's on every table over there except the middle one? Yeah, the bucket of sand. So we have specifically for fire, a fire extinguisher, 2 of them, the fire blanket, and then we've got a sand can on every table to throw away our burned out matches. All right, describe how to properly transfer solids. the question itself says the proper way to handle solids in lab is to, and I want to point that out because see how close the test hint was to the actual test question. Okay? The actual test question says the proper way to handle solids in the lab is to blank. And my test hint says describe how to properly transfer solids in lab. So I think sometimes people look at these test hints and say, well, I don't really get what that's saying, but some of them match pretty closely what the test question is. So what do? Pick it up with our fingers? Lick it? No. What's the piece of equipment that we used first? No, not tongs.
It's not those paper boats?
Well, we're going to put it in the massing boat, but what are we going to touch the chemical with? The scupula, right? So it's a scupula, not tongs. So use a scupula or a spatula to scoop up some solid and put it in the massing boat, and then you take it back to your desk and transfer it. You can just dump it in there after that. But we are not going to take the main container, the stock jar, over to our table and just dump some out. We're going to leave the stock container for everybody else, and we're not going to pick it up with our fingers. Describe how to insert glass tubing in a rubber stopper. What lubricant do we need to use for that? Glycerin. Glycerin. And after we put some glycerin on either the tubing or the stopper, you're going to grab the tubing close to the end and push and twist. What do we want to do for our hands before we do that? No, to protect them, what else? Gloves. Gloves, or wrap the glass in a towel or something. So in case it does break, then it won't go through your hand. Alrighty. When you first get the balance, describe how to use the balance. When you first get the balance, you get it out of the cupboard, you got it at your desk, you're ready to measure something, what do you have to do to it? Set it to 0. Okay, you're going to 0 the balance to make sure that it's working properly, starting from the right spot. And then what? Put your solid on the pan, and probably start by turning the dial, because usually we're measuring things that are pretty light. Okay, good. Some of these, when you read them, it's just like common sense. Envision yourself actually getting that thing out and working with it, and you'll be fine. When we measure liquids, if I said I wanted you to measure exactly 18 milliliters of liquid. No. How about exactly 20 milliliters of liquid? What would be the best, most specific device to use to measure liquid? Well, there's one better than a graduated cylinder. A burette. And then, what's the next best? A pipette. If we have the fancy pipettes, the glass ones that are actually made to the right size, then you'd use that. And then after that, it would be a graduated cylinder. And what would be a horrible thing to use to measure liquids? A beaker. Yeah. I know there are marks on it, but you don't want to use a beaker. Alrighty, describe what to do with excess chemicals in the lab. If you get too much, what should you do with the